Good afternoon. Welcome to week 7 of the NPTEL course on Calculus for Economics, Commerce and Management. This is the penultimate week, the second last week. So this is 8 weeks long course. We will have 8 such live problem solving sessions and 1 review session. So in all 9 such sessions, but this is the second last week, so week 7. We will just wait for a few more minutes for some more students to join, and then we will begin with the session. Okay, so let us begin with the class for today. The first question, it's a multiple choice type question. Consider the function defined on the interval -1 to 2 going to the set of real numbers defined by the following definition. Fx equals -x if x is between -1 and 0, and it is 2x cubed minus 4x squared plus 2x if it is between 0 and 2. Then we need to see which of these options is correct. Option A, the absolute minimum of f is attained at 0, 1, and absolute maximum of f is attained at x equals 2. The absolute minimum of f is attained at x equals 0, and absolute maximum of f is attained at x equals 1. Option C, the absolute minimum of, all these were for, I read the option B wrong. It is absolute minimum of f is at 0 and absolute maximum is at 1. Option C, absolute minimum of f is attained at x equals 0 and absolute maximum of f is attained at x equals 1.5. Or option D, the absolute minimum of f is attained at x equal to 0, 1 and absolute maximum of f is attained at x equals 1/3. So I will launch the poll for all of you. Please take a few minutes to answer. Okay, let us now discuss the solution. So we have the function definition. The function is from -1 to 2 to the set of real numbers, and the derivative of the function, since it's a piecewise function, so derivative is also going to be piecewise. In the same interval. And double derivative Now maxima and minima occur at the following. So minima, the condition for minima is minimum value of fx, and this for a continuous function it is at fx f prime x equals 0, and the double derivative should be positive. For maxima, it is the maximum value of the function, and again f prime x is 0, but the double derivative is negative. Now let us look at the value of the function at these interval endpoints. So one changing point is 0, f at 0 is 0 and it is continuous. Then at the one end of the interval at -1 it is 1, and at the other end of the interval it is 4. And now let us look at the condition for extremum points, which is f prime x is equal to 0, and this will be 0 at 6x squared minus 8x plus 2 equals 0, because -1 cannot be 0. So minima or maxima does not occur in the interval -1 to 0. It will only be in the interval 0 to 2. So these are the extremum values. Now f at 1 equals 0 at this extremum, and f at 1 over 3 this is 8 over 27. Now let us look at the double derivative. So f double prime at 1 equals 4, which is greater than 0, and f double prime 1 over 3 is less than 0, so this can be like a possible point for minimum, and this can be a possible point for maximum. Now we need to check whether indeed these are minima or maxima or not. So we see that the function value is at f equals 1 is 0, and this is also true for the function value at x equals 0. So 0 and 1 both are points of minima. Both are points of minima. And then the possible point for maxima was 1 by 3, and the value at 1 by 3 is 8 over 27, but this is less than the value at the end point at 2, which is 4. So x equals 2 is the global maximum, and x equals 1 over 3 is also a maxima, but it is a local maxima. So the correct option is option A. The absolute minimum is at x equals 0 and 1, and absolute maximum is at x equals 2. At x equals 1 by 3, it is a local maximum, not a global maximum. Okay, so we can proceed further. So I hope the distinction between local maximum and global maximum is clear. So global maximum, as the name suggests, is the absolute maximum of a function, and local maxima is like within an interval, within a small region, the function is having a maxima. So let's say if you have a function, if your function let's say looks like something like this. So you see that all these points, so this point is a local maximum, this point is also a local maximum, whereas so if the function is defined within this region, so this point is the absolute maximum. So this is just a simple example I just showed. Similarly, this point will be, this is above, this is below this, so this is absolute minimum, and this point is local minimum. So this is the distinction between local maxima and absolute maxima. Okay, so now we can proceed to the next question. Question number 2. Fix r greater than 0 and consider a circle of radius r. Then the maximum possible area of an inscribed rectangle is what? We need to select. Again, it's a multiple choice question, 4 options. I will relaunch the poll for the same. Take some time to answer the question. Okay, now let us discuss the solution. Let us first draw a diagram to better understand. So we have a circle. And we are inscribing a rectangle within the circle. Something like this. I need to little bit adjust the size of the rectangle. Yeah, so this is a rectangle inscribed inside the circle, and the circle has radius r. So this being the center of the circle, this is r, this is also r, and so is this also r. And let the side of the rectangle be this one a and this one b. So we clearly know by Pythagoras theorem, so this angle is 90 degrees. We know a squared plus b squared equals r plus r, which is 2r. 2r squared is 4r squared. So area of the rectangle A is a times b, which is a times, now we can use b as square root 4r squared minus a squared. So 4r squared minus b squared. Now for maximizing the area, we need to differentiate. We need to find the maxima of this function. So that's the derivative. We need to set it equal to 0. We are just doing simple algebraic manipulations to simplify. So this gives us a is square root 2 times r. So therefore b is square root 4r squared minus a squared, which is the following. Which is same as A. So it says this rectangle is essentially a square for maximizing area, and therefore A, which is equal to AB, which is same as A squared, is 2R squared. So the correct option is option C. And just by looking at it, you could say that options A and D are incorrect because the dimensions are not correct. The dimension for area is length squared. So it should be in terms of R squared, whereas for A and D the dimensions are simply length. Okay, so now we proceed to the next question. Consider the function f defined from the interval 1 to infinity going into the set of real numbers defined by fx equals x over log x. Then we need to select which of these options are correct. Option A, f has a local minimum at x equals e, which is not an absolute minimum. Option B, f has a local minimum at x equals e, which is an absolute minimum. Option C, f has a local maximum at x equals e, which is not an absolute maximum. Or option D, f has a local maximum at x equals e, which is an absolute maximum. Once again, I will refresh the poll, and all of you please try to answer in the poll itself. Please do not put up the solutions in the Zoom chat box. Please do it in the poll. Okay, time to discuss the solution. The function is fx equals x over log x. So the derivative is the following, we will use chain rule. For differentiation. F prime x is 0 for maxima or minima, and this will occur when the numerator is 0 because denominator is never 0. So this will occur at x equals e. Now f double prime x again we'll make use of the chain rule. Now the sign for the double derivative at x equals e we need to find out. And this is positive. So the double derivative is positive, therefore this point is minimum. Now for whether it is a local or absolute, we need to look at the limits at the end points. So let's look at the limits. Limit x tending to 1 f of x. This tends to infinity because ln 1 tends to 0. So this tends to infinity. Also limit x tending to infinity x over ln x. This also tends to infinity because x grows faster than ln x. So because x grows faster than ln x, this limit also tends to infinity. So x equals e is indeed both the local minimum as well as the absolute minimum. So the correct option is option B. X equals e is both a local as well as an absolute minimum. Sorry. Next question, state whether true or false. Now we have true and false type question. So root x is greater than ln x. It's true or false for all x greater than or equal to 1. I will launch the true false type poll for this one. Now time for the solution. So let's say fx is equal to x and gx equals ln x. So f of 1 equals 1 because x is greater than or equal to 1, so this is just the endpoint we are checking. So clearly at the endpoint f1 is greater than g1. Now let's look for all x greater than 1. So what we need to show is, we need to show that fx grows faster than gx. So let us consider the limit gx over fx sorry, this is root x. Now this is of the infinity over infinity form, so we will make use of the L'Hopital's rule. So this is same as limit x tending to infinity g prime x over f prime x and this is going equal to 0. So this means that fx grows faster than gx. So that means fx is greater than gx for all x greater than or equal to 1. So this is indeed true, and same thing we can use here. Here I just said that this limit tends to infinity, and how you can, again you will use L'Hopital's rule. And this clearly goes to infinity. Similar thing we just stated in the previous question, but here a similar thing we actually derived and showed it over here. So I hope it is clear up until now. Okay, seems like there is no question, so we can move to the fifth question. So if you have any doubt, feel free to put it up in the Zoom chat box, or you can simply even unmute yourself and ask. Fifth question. The function gx equals x squared minus 3 has no, so we need to select which option is true for this particular function. Option A, it has no point of local maximum or local minimum. Option B, a point of global maximum and a point of global minimum. Option C, a unique point of local maximum which is not a point of global maximum. Or option D, a unique point of local minimum which is a point of global minimum. This time I will start the multiple choice type poll. Okay, so let us look at the solution. So f prime x is 2x, and for this equals 0 we have x equals 0, and sorry, not this is not f, this is g, so g prime x, and the second derivative is 2, which is positive at all times. So this is the point of minimum. And it is also a global minimum. In fact, if we draw the plot, it's actually a parabola, something like this. A parabola does not look like a parabola. Let me try again. I guess this is better, probably my best attempt. Maybe better. Okay. And that's the plot, and this point is -3. This is 0. This is √3, and this is -√3. So clearly you can see that this is local minimum as well as global minimum. So this function has a point of, oh sorry, not global maximum. There is no maximum because it just goes on to infinity on both ends. X going to plus infinity, x going to minus infinity. It just keeps on going to infinity. So it has a unique point of local minimum, which is also a point of global minimum. Option D is the correct option. Okay, so we are halfway through for today. 5 questions done, 5 more questions to go. Let us take a short break of 5 minutes and then we will get back. Okay, so I hope all of you are back. 2 hour long sessions can sometimes be a bit tiring, so that's why we take like these short breaks in between. Question number 6. The function hx equals x cubed minus 6x squared plus 11x minus 6 has, we need to select which option, a point of global maximum and a point of global minimum, 2 points of local maximum and no point of local minimum, 1 point of local maximum and 1 point of local minimum, or 2 points of local minimum and no point of global maximum. Once again, I will refresh and relaunch the poll. Take some time to answer. Okay, so let us now look at the answer. So this is the first derivative, and for this to be equal to 0, it's a quadratic equation, so the roots will occur at the following points. This is the second derivative, and we need to check the sign of the second derivative for x at 2 plus 1 over root 3. So this is basically 2 plus 1 over root 3 and 2 minus 1 over root 3. So at this particular x, h double prime x is the following. So this point corresponds to minimum. So now these points are actually local maxima or minima and not global. Why not global? Because global maxima or minima will be plus minus infinity, because you see if x tends to infinity, hx tends to infinity. So if x tends to plus infinity, hx tends to plus infinity. If x tends to minus infinity, then hx also tends to minus infinity. So it is a local minimum and maximum, but not global. So correct option is option C, 1 point of local maximum and 1 point of local minimum. Moving ahead. The seventh question, find the local maxima or minima and global maxima or minima, if any, for the following functions. So first function is fx equals 3x over x squared plus 1. Second function is fx equals x plus 1 over x. So these are now subjective questions, so it's not MCQ anymore, so no more poll. You have to try it out on your own and take some time, and then we will discuss the solution. Okay, let us now solve. I hope all of you have tried. So the first function, let us look at the derivative. Second derivative, we will look at it now. Now let us check the sign of the double derivative at each of the extremum points. Sorry. Now the value of the function at each of these points is the following. And also we need to check the limit at x tending to plus minus infinity. So this is 0. And this is also 0. So clearly x equals to 1 is not just local maxima, it is also global maxima, and x equals to -1 is global minima. So that was for part A. Now part B, a different function. Setting the first derivative equal to 0 to find the extremum points. Now double derivative. Now sign of double derivative at the extremum points. Value of the function at the extremum points. And now we need to check the limits. So this tends to infinity, and at negative infinity it tends to negative infinity. So clearly x equals to 1 is this time not a global maxima or minima, it is local minimum, and x equals -1 is local maximum, because the actual maxima or minima occur at x tending to plus minus infinity. Next question. Question number 8. The average cost of a firm is given as follows: 15 minus 6q plus q squared plus 1 over q, where q is the input. Find the total cost and the marginal cost. Sorry. Now let us solve. So average cost is total cost over the input so total cost is simply average cost times the input that's the total cost. Marginal cost is the derivative of the total cost function. So that's it. Very simple. It was just based on the definition of total cost, average cost, and marginal cost. Now the ninth question. The demand function for a goods company is given by the relation P equals 50 minus 2Q, while the total cost is given by C equals 16 plus 2Q. There are two parts to this question. So first part is find appropriate relations and compare the graphs of total profit with total cost and find the break-even points for the firm. And part B is compare the levels at which profit and revenue are maximized. Okay, so the solution: total revenue is the following. Now total profit is total revenue minus total cost. And break even point will occur when the total profit is 0. That is, revenue equals cost. So the roots of this gives us Q equals this is the value. Now square root 136, let us try to simplify that. Let me pull out my calculator. So this is the following. So clearly the correct option will be 12 plus 11.66, which you can say approximately 12 plus 12, which is approximately 24. Of course, 12 minus 11.66, that will be a fractional number. It is less than 1, and quantity or the input cannot be less than 1. It needs to be like a positive number and greater than 1. So as a result, the quantity is like is 12 plus root 136, which is approximately 24. Now for part B, maximizing the profit and revenue. So for that, let us look at the derivative of the profit. For maximizing, we need to set the derivative equals 0. And we need to check the sign of the double derivative. So that means maxima is at Q equals 12. Now total revenue, the derivative is the following. Setting it equal to 0. The double derivative. So maxima is at Q equals 25 by 2, which is 12.5, so approximately 13. Finally, the last question for the day, question number 10. Prove the following relations. So marginal revenue as a function of the elasticity of demand, and the demand function. And part B is, if profit is maximum at Q naught, then we need to show that the marginal revenue is same as marginal cost at Q naught. So now we will discuss the solution. Last problem for today. Part A. The marginal revenue is the derivative of the total revenue function Total revenue is P times Q, and using the chain rule we get the following. And this is 1 over epsilon d, that's the definition for elasticity of demand. Now this G is profit, which is total revenue minus total cost. The derivative at Q naught is 0 for maximum. Now this first term is marginal revenue and second term is marginal cost. So this gives us marginal revenue equals marginal cost at Q naught. So this solves the final question for today, and it brings us to the end of today's session. Thank you all for joining, and we will meet once again next Saturday at 3 p.m. So that's it from my end, and all of you can now leave the Zoom meeting.